In this video, we're going to talk about some of the things that we usually discuss when we're talking about lines in an algebra class. And you can't talk about lines without having a discussion about slope. So let's start there. The slope of a line helps describe the steepness of the line. In fact, many people have it memorized as the ratio of the rise over the run. It's a way of quantifying how steep a line is. So let's look at a line and compare the rise to the run and refresh your memory on how slope works. So let me put a line right here. Now, when you're calculating the slope of a line, you can grab any 2 points on the line and calculate the rise over the run. Let me mention that on this graph, I'm going to assume that the increments are the same in the x direction and y direction. Let's let the increments be by 1. So that's 0, 1, 2, 3 in the x direction and 1, 2, 3 in the y direction. And we can grab any 2 points. We'll grab this point here and this point here. And we take the ratio of the rise to the run. So to get from this point, I would go up 3 units and over 3 units. So the slope of that line would equal 3 over 3, which is of course just 1. But I could have grabbed other points. I could have grabbed this point down here and this point here and calculated the ratio of the rise to the run. And I would have had 4 over 4, but notice 4 over 4 would give me the same value of 1. So we could say the slope of this line right here equals 1. And remember, we use m for slope. Let's draw another line. I'll have it go through this point and then this point and this point right here. So if we draw a line that goes through those points, we would have a line that looks like this. Let's calculate its slope. Grab any 2 points and I'll use this first point and the third point that I drew. So to get from one point to the next, I would go up 2 units and over 8 units. So the slope of that line would be 2 over 8, which would reduce and give us 1 over 4. So the slope of this line is just 1/4. Let's draw another line. Let's have it go through these points. This point, this point, and this point. So this one's steeper, and we'll draw our line that goes through those. And here it is. Can you see what the slope is? I'm grabbing any 2 points. I'll use this first point or the second point and the third point, and I would go up 3 and over 1. So the slope of that line is 3 over 1, or just 3. And let me point this out. This line right here that wasn't very steep had a slope of 1/4. The line that was a little bit steeper had a slope of 1, and this line that was steeper still had a slope of 3. But they all had a slope that was positive. And notice that they all were increasing from left to right. In other words, going uphill if you were walking on it from left to right. But let's look at some other lines. So let's calculate the slopes for these lines, and we'll start with line 1. We grab any 2 points we like. I'll choose this point, and how about this point? And remember, we calculate the rise over the run. So the rise, notice, is down 2 and right 4. So I would have a slope of -2 over 4, which is equal to -1/2. But I could have started with this point on the right first. Notice if I had done that, I would have gone up 2, but now left 4, that would be a negative 4, and now I would have a slope of 2 over negative 4, which is again negative 1/2. So it doesn't matter which point you start with. And notice this line had a slope that was negative, and that is because it's decreasing from left to right. What about a horizontal line, like line 2? Let's calculate its slope. Grab any 2 points, and you look at your rise over your run. I'll use these 2 points. My rise is 0, and my run is 3. And I get 0 over 3, which is 0. So that reminds me that any line that is horizontal has a slope equal to 0. And then we move to our vertical line. It is drawn in as line 3. Grab any 2 points on this one. And notice that we would have a rise of 4. And this time the run, that is side to side, is 0. And we have a number that is undefined. And we know that any vertical line has undefined slope. So to summarize, a line that is increasing from left to right would have a positive slope. Any line that is decreasing from left to right has a negative slope. Any horizontal line has a slope that's equal to 0. And any vertical line has a slope that is undefined. Suppose we were supposed to calculate the slope of a line passing through a couple of given points when the line wasn't provided. Well, one way is to just graph the line. For example, suppose I'm supposed to calculate the slope of the line passing through 7, 5, and 2, 4. I can put 7, 5 right here on my graph, 2, 4 right here. I could just draw a quick sketch going through those 2 points. And then I could calculate my slope by just counting my rise over my run. And I would see that the slope for this line is 1/5. But what if the points weren't as nice as that? Or I just didn't want to graph them. Let's talk about where those numbers come from. 5 comes from the fact that we're looking at the difference between 2 and 7 right here. We went from 2 over to 7 for a difference of 5. So that set 5 comes from 7 minus 2. Similarly, this 1 comes from the fact that we were down here at 4 and we went up to 5 for a difference of 1. So the 1 comes from 5 minus 4. So let me write that right here. We have 5 minus 4 over 7 minus 2. And we can calculate the slope that way. Notice in the numerator, it is the difference between the y coordinates. And in the denominator, it's a difference between the x coordinates. Let's write that out. To calculate the slope of the line, if you have points x1, y1, and x2, y2, the slope is calculated by finding y2 minus y1 over x2 minus x1. And it actually doesn't matter which point you use first. I could write the formula as y1 minus y2 over x1 minus x2. It does matter that we're consistent between the numerator and the denominator, though. So right here, when I started with y1 in the numerator, I started with x1 in the denominator. Over here, I started with y2 in the numerator, and I started with x2 in the denominator. So let's do another problem. The example will be to find the slope of the line, still the same directions, given that the points are -11, 4, and -3, -22. And maybe we wouldn't want to draw a picture and to calculate the slope. So let's just use our formula. M equals, we grab our y coordinates first and subtract, and you can calculate it either way, -22 minus 4 or 4 minus 22. I'll just do -22 minus 4. In the denominator, since I started with -22 in the numerator, I must start with -3. So I have a -3 minus -11. So when we do the arithmetic, we have -26 in the numerator, and we have -3 plus 11 in the denominator, so that's 8. A slope is just a number, so it should be simplified the same way you would simplify any other number. So that is reducible, and the slope of the line that passes through -11, 4 and -3, -22 is -13 fourths. Next, I want to remind you how to graph equations of lines. We often have equations in the form y equals mx plus b. We call that slope-intercept form. And when our equation is in slope-intercept form, the coefficient of the x, right here, this m, represents the slope, and the b, the constant right here, represents the y-intercept. So if an equation is in slope-intercept form, it is particularly easy to graph. So let's graph y equals -2x plus 3. We can identify the slope by looking at the coefficient of x, and it is -2. We can identify the y-intercept as 3. I'm going to write it as the ordered pair 0, 3. So we can use that information to graph the line. I'm going to label my grid so we know we're going by ones in both the x direction and in the y direction. So we need to start with a point, so we'll start with that point 0, 3. Put that on our graph, and we use our slope of -2. Remember, a slope can be considered a ratio, so -2 over 1. So if we use our slope, that means we're going down 2, 1, 2, out over 1. I often go find some more points using that same ratio. Down 2 over 1, down 2 over 1. So when I put my ruler down, it looks a little bit nicer. I can see where the graph should be a little bit better. So here's my line right here. And it's done. Let's graph another one. You'll notice this one is not in slope-intercept form. But that's not a problem. We can put it in slope-intercept form. So let's do that. We'll subtract 3x from both sides and divide by -4. And when we do that, we end with y equals 3/4 x minus 2. And now the slope and y-intercept are just looking at us. The slope is 3/4, and the y-intercept is -2, or as an ordered pair, 0, -2. So we can graph that one pretty easily. We go to our y-intercept of -2. And we start at that point and use that to count a slope of 3/4. So that means up 3 over 4. So up 1, 2, 3 over 1, 2, 3, 4. Here's a point. That's all we'd need to draw a line, but I like to find more. So I'm going to go up 3 again over 4, up 3 again over 4, and then I have a nice look at what the line's supposed to look like. I'm going to just do this one freehand this time, and here's my line. How about a line, an equation that looks like this? Let's graph this one. Y equals -6. Now this one is actually already in slope-intercept form. It's just that you don't see the x because its coefficient is 0. In fact, we could write it as y equals 0x minus 6. So my slope is 0 and my y-intercept is -6. So if I were going to graph this one, I would go down to -6 on the y-axis, and a slope of 0 means we just have a horizontal line, and it's done. I hope you remember now that y equals a constant is always a horizontal line. So if you were asked to graph y equals 7, you actually don't need to do any more than go to the y-axis, go to 7, and draw a horizontal line. And it's done that quickly. Do you remember that equations of vertical lines look very similar? Graph x equals -3. Now this one can't be put in slope-intercept form because remember slope-intercept form is y equals mx plus b, which implies that there's a 1x somewhere, and this one doesn't have a 1x. But do you remember what it looks like? It is the line that goes through an infinite number of points that have an x-coordinate of -3. For example, -3, 2, -3, 5, -3, -1 are all points on the line. And if I came over to my grid and graphed them, -3, 2 would be here, -3, 5 is here, -3, -1 is here, and you see that we have a vertical line. X equals a constant is always a vertical line. And remember, its slope is undefined. Next, I'd like to talk about how to write the equation of a line if you're given some information about that line. The first one I'd like to do is to write the equation of the line passing through 0, 23 with a slope of -6. Notice that 0, 23 is a y-intercept because its x-coordinate is equal to 0. So for this particular line, I know the y-intercept, I know the slope, so I could write the equation very easily in slope-intercept form as y equals -6x plus 23. But what if you weren't given the y-intercept? We have this next problem. Write the equation of a line passing through 52, 3 with a slope of 5. Now there are a couple of different ways to do it, but I'm going to show you the way that I think will be most useful to you if you move on mathematically. Let me draw a picture of what line we're trying to find the equation of. 52, 3, we'll put that way over here. Here is my point 52, 3, and I have a slope of 5. So here's my line. Its slope is 5. Now, I don't know the y-intercept, that's the issue. But let's name some other point on the line. Let's let this point right here be the generic point xy. And xy represents any point on that line. Now, I can calculate the slope with those 2 points. I have y2 minus y1 over x2 minus x1, remember, is equal to the slope. So I have y minus 3 over x minus 52, and that better equal 5. And I have the equation of the line. And you might look at that and think, well, that doesn't look like the equation of a line. I know. So let's improve the way it looks. Let's clear out the fractions by multiplying by x minus 52. When we do that, we will have y minus 3 equals 5 times x minus 52. Let's distribute. So we have y minus 3 equals 5x minus, what is that, 260. And we'll add 3 to put the equation in slope-intercept form. And I didn't even state how to finish, but let's let it finish in slope-intercept form. So here it is. In slope-intercept form, y equals mx plus b. Slope-intercept form. But let me take you back to this line right here. That's actually a special form as well. It's called point slope form. Point slope form. And it's a nice form to use when you're writing the equation of a line, when you know a point and you know the slope. And it looks like this. Y minus the y coordinate of your point equals m times x minus the x coordinate of your point. So instead of drawing a picture and writing my extra point xy, it is totally okay to just use this point slope form. So let's do that on this same page. I'm going to move up a little bit so we have room, but I still want you to see that point slope form. Let's have the question be this: to write the equation of the line passing through to 7 and negative 1, 5. Now, if you look at that, you might think, well, shoot, I don't even have the slope this time. That's okay. We just need to do a little bit more work first. We need a point and a slope to write the equation of the line. So let's start by calculating the slope. So we'll have 5 minus 7 over negative 1 minus 2. And we have a slope of negative 2 over negative 3, which is just a positive 2/3. So now we have the slope and we have a point. In fact, we have 2 points. You can choose either point you like. I'll just use 2, 7. So now here's the information we have. The slope is 2/3. The point is 2, 7. We're trying to come up with the equation of the line. Let me write the point slope form right here. It's y minus y1 equals m times x minus x1. So I'm substituting in the slope and the point. So I'll have y minus 7 equals 2/3 times x minus 2. And we have the equation in point slope form. Let's continue and go to slope-intercept form. So we'll distribute the 2/3. So we have 2/3 x minus 4/3. And we'll add 7. So we have y equals 2/3 x plus a constant. So let me come over here to my scratch paper and figure out what negative 4/3 plus 7 is. I need a common denominator of 3. So I have negative 4/3 plus 21/3. That's 17/3. So my equation is y equals 2/3 x plus 17/3. and I have the equation in slope-intercept form. So remember, right here it was in point-slope form. And that's just a nice form for writing the equation of a line. And down here, it's in slope-intercept form. Now, do make sure you pay attention to what form you're being asked to put the equation into. Let's do another one. In this next one, we're going to write the equation of the line passing through -8, -1 that is parallel to the line y equals -7x plus 100. And in this one, we're asked to write the equation in general form. So there are a few things in this one that we haven't talked about yet. Recall that lines are parallel if they have equal slopes. So when we're being told that the line that we're to write the equation of is parallel to the line y equals -7x plus 100, we're being told it has the same slope. So notice right here, the slope is -7, so the slope of our line will also be -7. And we know it passes through the point -8, -1. So to write the equation of the line in point-slope form, we'll use y minus y1 equals m times x minus x1. So y minus -1 equals -7 times x minus -8. And notice as soon as I said minus a negative, I was going immediately to plus. And that's totally okay. Now I have the equation, and it is in point-slope form. Well, what's general form? Well, in general form, we're going to write it this way, in the form ax plus by equals c. Now, there is some variation from textbook to textbook about what you call this form. Some books call it standard form, and some books call it general form. But in any case, we're going to put our equation into this form, ax plus by equals c. So the x's and y's on one side and the constant on the other. So we have some work to do. Let's distribute -7. Y plus 1 equals -7x minus 56. We need the x's and y's on the same side, so I'm going to add 7x. So I have 7x plus y plus 1 equals -56. And I need the constant on the right, so I'm going to subtract 1 from both sides, and I have 7x plus y equals -57. And this problem is finished. Here we are in general form. So when I'm writing the equation of a line, I don't really care initially whether it asks to write the answer in general form or slope-intercept form. I always start the same way. I start with the equation in point-slope form if possible. This one will be to write the equation of the line passing through 4, -7 that is perpendicular to the line with the equation 2x minus 5y equals 3. And we're going to present our answer in slope-intercept form. But let's talk about what it means for lines to be perpendicular. Remember, their slopes need to be opposite reciprocals. For example, if one line has a slope of 2/3, the line perpendicular to it would have a slope of -3/2. If one line has a slope of -7, the line perpendicular to it would have a slope of +1/7. So it's our job to find the slope of this line right here and then take the opposite reciprocal of that number. So let's start by putting this equation in slope-intercept form, because this equation is not in the form where its slope is visible. So let's start by solving for y. So we'll subtract 2x from both sides. We'll divide both sides by -5. So we have y equals 2/5 x minus 3/5. So the slope of the line that we were given is 2/5. So the slope of the line that we want would have a slope of -5/2 because I took the opposite reciprocal. So we have -5/2 for the slope. We have the point that is 4, -7. And now it's like the previous two problems that we've done. We're going to use point slope form. That's y minus y1 equals m times x minus x1. We pop in our slope and our point. So we have y minus -7 equals -5/2 times x minus 4. Now I'm peeking to see what form this is supposed to be presented in. Slope-intercept form. So that means down here at the end, it needs to be in y equals mx plus b form. That's what we're shooting for. So let's distribute the -5/2. So we have y plus 7 equals -5/2 x plus, let's see, we have 5/2 times 4. That gives us 10. And when we subtract 7, we get y equals -5/2 x plus 3. And now we have the equation that is perpendicular to the given equation. Notice these two slopes, +2/5 and, +2/5 and -5/2. And the line goes through 4, -7. Let's finish with this problem. We're going to write the equation of the line passing through 45/6 that is vertical. We'll recall that a vertical line has a slope that is undefined. So we can't use the formula that we did on the previous problems. But let's draw a picture of the line we're talking about. Here's my grid. Here's my x-axis and my y-axis. Just a quick sketch. 45/6. Let's say it's right here. So this is 45 and this is 6. And we're looking for the equation of this line. Well, do you remember what the equation of vertical lines look like? They always look the same. They are x equals some constant. Well, what could x possibly equal in this problem? The graph goes through this point 45/6. This is the point 45/0. And of course, if you find other points on the line, you'll see that the x-coordinate is always 45. So the equation of this line is x equals 45. And it's done. I hope you'll enjoy working with some lines.